In this example, f of xy equals natural log of the quantity x squared plus 4y. And we're going to find all four second order partial derivatives. For the first order partial derivative with respect to x, fx is a partial with respect to x of the natural log x squared plus 4y. Use the chain rule to be 1 over x squared plus 4y, and then partial with respect to x of the inner function x squared plus 4y. Partial with respect to x is treated as the variable, then it becomes it becomes 2x, and this one becomes 0. So the first order partial derivative with respect to x is 2x over x squared plus 4y. And then partial derivative with respect to y of natural log x squared plus 4y is 1 over x squared plus 4y, and then partial with respect to y of x squared plus 4y. We see y as the variable, the rest is the constant term. So this will be 4. Therefore, we have 4 on the top divided by x squared plus 4y as the first order partial derivative of the function with respect to x and with respect to y respectively. So next, for the second order, that's xx. So we find the partial with respect to x of fx, or the partial with respect to x of 2x divided by x squared plus 4y. We see x both numerator and denominator. This one we're going to use the quotient rule. I put the note here. The quotient rule. Recall the quotient rule is low D high minus high D low. High D low, draw the line, low square. Draw the line, the low square, which is x squared plus 4y squared. The low, which is the quantity x squared plus 4y. The D high with respect to x. I'm gonna just be careful with this because we do with respect to x, 2x. And then subtracted by the high, which is the 2x. And then partial with respect to x of the denominator, or the low, which is x squared plus 4y. And then simplify to be x squared plus 4y multiplied by 2 minus 2x times 2x, all divided by quantity x squared plus 4y to the power 2. Now we're going to simplify the numerator. This becomes 2x squared plus 8y minus 4x squared. So we're going to get the simplified form of the second partial derivative with respect to x. Right here, fxx equals 8y minus 2x squared divided by the quantity x squared plus 4y squared. 1 down. And then the next one is the partial with respect to x with respect to y. That means we find the partial with respect to y of the first partial derivative with respect to x. We can use the same quotient rule where we see y as the variable on the bottom there. Now we do the low D high minus high D low, draw the line low squared. Low squared, which is x squared plus 4y, quantity squared. The low is x squared plus 4y d high means the partial with respect to y of 2x minus the high, which is 2x, multiplied by the partial with respect to y of x squared plus 4y. With respect to y, we're going to treat y as the variable. For the first part here, we do not see y in there, so that means going to be 0. So the first term is gone. That will give us negative 2x times 4 divided by the quantity x squared plus 4y power 2, or negative 8x divided by quantity x squared plus 4y all to the power second as the second order partial derivative with respect to x and with respect to y. Next one, fyx, which is the partial derivative with respect to x of the fy, or the partial with respect to x of 4 over x squared plus 4y. We see x over here, so then either use the quotient rule or you can rewrite it as the power form, like 4 times x squared plus 4y to the power negative first, and then use the general power rule. Since we target only the x, we don't have to use the full form of the quotient rule. So this will be 4 as a constant multiple. The general power rule, we have negative 1 times the quantity x squared plus 4y to the power minus 1 become minus 2, and then partial with respect to x of x squared plus 4y. This piece will give us 2x. Put them all together will be 4 times negative 1 times 2x, the power negative second. We can bring it down to the power 2 of x squared plus 4y. Therefore, the fyx would be in the form of negative 8x divided by quantity x squared plus 4y power 2. And the last one, fyy, or the partial with respect to y of the partial with respect to y. I'm going to use the same technique by rewriting in the form of 4 times the quantity x squared plus 4y to the power negative first, and then treat y as a variable, the rest as a constant term. So we have 4 as a constant multiple. Use the general power rule to find the derivative. Going to be negative 1, and the power becomes the power negative second, and find the partial derivative with respect to y of x squared plus 4y. And this piece is going to give us 4 because we treat x as a constant term. Then we have 4 times negative 1 times 4, and the power negative second goes down to the bottom, becomes the power positive second. We write it to be fyy equals negative 16 divided by x squared plus 4 times y to the power second.